Good afternoon. I am starting this class 1 minute early, and you can see that time in the lower right corner just to honor these young children who have come to this class much before the time of this class. So if you are watching the video recording, which Google Analytics show that most of the people they watch the recording and not the live, you can skip the first minute or so because I will take their names and wish these people good afternoon who have come to the class much before time. Shivangi Saha, Visalakshi Chillar, Khwaish Jaiswal, Mayank Gangwar, Shreyashi Jha, Mridul Sharma, Yash Jolly, Akshat Bahel, Mridul Sharma, again Deepak Rajput, Monia Mehta, Navnoor Kaur, Parth Sharma, Ansh Bhatia, Pratham Gupta, Sanna Srivastava, good afternoon, good afternoon. Priyanshu Yadav, good afternoon. Ashi Kumar, okay, must have been two times. Udbhav Yadav, Kriti Rao, Harmesh, Abhilash Singh, Ritvik Bhatia, Abhi Abraham, Ritesh Wadhwani. Good afternoon, everyone, and thank you so much. Your presence, if you can see 26 people are there, it's just now it has got become 2 o'clock here, the time of the class. 24 people on time, rather before time. Arnava Verma, Isha Dhal, Ritesh Wadhwani, good afternoon, welcome, thank you. Actually, your presence motivates me. So today, Umang Gupta, good afternoon. So today we are going to have the study the motion of connected bodies. When bodies are connected to each other, we are going to study that. And we will see what all new terms we need to understand to study the motion. But today's life will be little bit simpler, that we will not consider friction. Now, if I place these blocks, so far I used to have one block, but because today the motion is of connected bodies, I will have two blocks. If I place these two blocks on a very smooth surface like book from H.C. Verma sir is one of the smooth surfaces, very smooth surfaces, then you can approximate that friction to be zero. Kashika Sharma, Kevin Jacob, Manya Rehani, Kanishk Sihag, Mehul Pundir. Thank you. Good afternoon. But gradually, as the class starts, I will not be able to respond to your good afternoons. So if I place these blocks on a frictionless surface, we can approximate that situation. But even better, that in some class later on, we will study friction also, and we will learn how to handle friction also. But for today's class, friction will not be considered. So, Mehul Pundir, last one to join or last one to wish? Now we have 38 people, and I am going to start, formally going to start the class. So let me increase the size of the video as I ask you one question. Rishika Gosal, welcome. I'll increase the size of the video so that you are able to see the activity little better. So this is it. These are the two blocks, bringing it, focusing it here. Okay, I hope it is visible that there are two blocks kept joined together by a string, and I am going to pull these blocks using this string. Let me make it a little bit better. Good afternoon, Adrian. I hope things are better. You are able to see them. I'm going to pull it using this thread. Okay. And as I said, today we are not going to assume friction. We will assume rather that friction is not there. We will assume this surface to be frictionless. The surface between there is no friction between these two, Okay. Now, as I pull it, say this is my M1, this is my M2, and I pull it with some force. How much force? Let's say 5 Newton force. I am pulling this block with some force P, which is equal to, let's say, 5 Newton. Shikha Kotwal, good afternoon. My question to you is, Will you be approximately be able to do that? That you press my hand with your finger with a 1 Newton force. Can you do that? How much is 1 Newton? Now let me give you the answer because we don't have that privilege of face-to-face interaction. 100 gram, 100 gram. Now usually you buy vegetables also half kg, sometimes 1 kg. If it is potato, tomatoes, it is 1 kg or even more than 1 kg. But usually vegetables you buy for half a kg. Enough. Uh, well, there is something to be discussed there, whether that is kilogram or that is Newton. There is, but then you would have seen in your labs or in the shops those weights kept there. If you can get 500 gram weight, that is 5 newtons. If you get 100 gram, now if you have seen that 100 gram, that's a small weight. Let me show it to you. This weight is 200 gram. This is a small weight. It's usually found in the labs. This is 200 gram. So if I put it on my hand, the force on my hand is 2 Newton. Now just imagine if it would have been 100 gram, then the force on my hand would have been 1 Newton. 1 Newton. 200 grams on my hand is being pushed down by a force of 2 Newton. So coming back to this question which we were doing, this situation that we were doing, I am pulling, say, this block which I am calling M1, I am pulling it with a force of 5 Newton. 5 Newton. My question to you is, and you see M2 is also getting pulled up. My question to you is, again I am doing it, I am pulling it with force P, which I am saying, let's say 5 Newton. My question to you is this block M2 also getting pulled by 5 Newton? If you want, you can put it in the comments. I will repeat my question. I am pulling this M1 by this, applying force on this string, which if you can see the color, this is pink in color, this is deep brown in color. I am pulling it with a force of 5 Newton. My question to you is, and you can see this is also getting pulled along because they are connected with this string. My question to you is this block M2 also getting pulled by a force of 5 Newton? Pratham, Priyanshu, Udbhav says no. Shikha Kotwal, they say yes. Kevin says yes. Aman says yes, Aditya says yes, Deepak says yes, Mayank says yes. No, Mayank says no. Huh. Some more people, if you want to respond, there are 49 people. If you want to respond, this is your time to respond. It's showing 46 here, but in the chat it's showing 49. Might be, there is a delay. So let me, in the time when you are responding, let me reduce the size of the video so that I can explain this thing to you a little bit better. So lot of yes, no also, Ashmita, Adrian, Dev, Roy, no, but Parth, Rishika, Priyanshu, Ritvik, Akshat, no, Akshat says no. Sir, it is getting pulled by strings tension, okay, but Mudit, my question is it getting pulled by 5 Newton? So this diagram is there in front of you. I have pulled M1 and let's give some masses, some numbers to it, so that later on when we are calculating things, it is easier. Say M1 is 3 kg, and because M2 is a smaller one, so let me put it as 2 kg. Okay, so as they say in Hindi, that literature, कि इनके जन्म की तिथि के बारे में विद्वानों में भेद है. So today the class is split. 45 people showing there 45. Here the number shows little different. In this one, in live feed, 44, but there it shows 45. Whatever. But these people are divided. They are split. It is getting pulled by a force less than 5 Newton. Okay, Mayank now says less than 5 Newton. Somehow, many of you have impressed me with your common sense. And somehow I'm seeing gradually the answers are changing and it is going towards no. Okay, so let's discuss few things, and we will have to uh, learn few things in this process, and these are the terms that we will have to learn. One is tension, one is a thrust, and the third one is spring force. These are the terms that we will have to learn. We will concentrate on tension first, because right from the beginning I have been telling you that one of the purpose is to keep the classes as practical, as utility based as possible. So whenever we need something, we go and we learn, and then we come back. Now I need this tension today. So let me quickly talk about this tension and how to show this tension. See, I have this string. I hope I get a color which is lighter color. Let me choose a color which you can see. This color. I have this string, and my right hand and my left hand say they are pulling this string. Now listen carefully. If the string is loose, my right hand and my left hand, they are free to do whatever they want to do. But if the string becomes tight, now there is a restriction on my right and left. They cannot go beyond this limit. Within this, they could have moved anywhere because the string was not tight. So when the string becomes tight, it plays some role. And what is that role it is playing? It is this tightness in the string. This tightness in the string is applying a force on my right hand, and when it is tight, it is applying a force on my left hand. On my this hand, this string is pulling my this hand in towards left. It is pulling my right hand towards left, and it is pulling my left hand towards right. The tightness in the string. When there is no tightness, nothing. So one thing that I want to tell you is, if the string is tight, tension is basically related to tightness in the string. Tightness in the string, and as you could see it, it is basically related to pull. When it was being pulled, only then you see the string was getting tight. Okay, and how does it act? If there are two masses connected by a string which is tight, then this mass M1 and M2, remember this was my right hand, let's say this was my right hand, this was my right hand, it is pulling, the tightness in the string is pulling M1 towards this side, and if the string is tight, then this mass is getting pulled in this side. So tension is represented by a pair. It acts in pair, and it is represented like this, double arrow like this. Why? Because whichever mass is this side will experience a force in this direction, and whichever mass is this side will experience a force in the opposite direction like this. So tension relates to basically tightness in the string, and it basically acts when the string is pulled. Now just to make things clear, I will tell you a bit about thrust also. Thrust acts when something is between the hands, say, and you're pushing. Thrust is basically related to push. When does it act? Say two hands and you push it. Push it. I'll show it to you in another way. If you push the hands like this, there is a tightness in this rod. If you push it like this, you will see this hand was getting pushed. Do you see that mark on my hand? Why? Because this rod was pushing this hand away. This rod was pushing this hand away. There is a mark on it. So thrust is basically related to push, and it is represented like this. Pair of outward arrows. So do you see the difference between the two? Tension and thrust. Do you see this difference between these two? Tension is inner arrows. Sir, does a rocket work on the concept of thrust? Well, that thrust is a general word which is push. Yes, it is thrust because it pushes away. But then it's not exactly, it's not. In one of the classes, I will take a balloon and open its mouth. And you know what happens? This balloon goes like a rocket, it goes off. Hai na? The air comes out and it goes off. It's a very common, say, call it misunderstanding or misconcept. And it's a very common way of explaining that the air coming out pushes the air out and that pushes the rocket up. See, once you go a little bit higher in the atmosphere, there is no air. There is nothing to push. So this very common explanation, I have some problems with this kind of explanation. But in one of the classes, I will teach you this, that how do you explain that when you open the mouth of the balloon and the balloon moves away, how do you explain that movement? Because that is similar to your rocket wala. So Ritesh, thank you for asking this question. Your question will be answered in due time, but not today. Okay. But thrust means push. Okay. And this is how we show it. Now, just to make it clear, a rod, if you join two things with a rod can have both tension and thrust. Both are possible. How? You join two bodies with a rod, you can pull them away. Yes, it is possible. You can join two bodies with a rod, and if you pull one, another one, if it is joined properly, then you pull it, another one will be pulled. You can pull, you can also push. So using a rod, in a rod both are possible, tension and thrust both are possible, but in a string only tension is possible. You cannot pull two things together by joining them with a string and you are pushing them. If you push them, the string becomes loose. That doesn't work. But if you have joined two masses by a rod, then you can pull them, you can push them. So in a rod, both tension and thrust are possible. In a string, only tension is possible. Okay, coming back to the illustration that we were using, we have two blocks and I am pulling these two blocks uh, with say M1 which we have taken for 3 kg, M2 which we have taken for 2 kg. I am pulling this 3 kg with 5 Newton and my question is, and when both are moving together, my question is this M2 also getting pulled by 5 Newton? Note one thing, note one thing, and let me add some terms here. So this is the diagram. I am pulling it with 5 Newton and here there is a tension in the string. There is a tightness in the string here, T. And so my question, if I rephrase my question can be rephrased like this, that is P and T, are they equal? Or is T less than P, or is T more than P? All these kind of things. That's what my question can be rephrased as. Okay, look at one thing. Now observe. I'll draw the diagram again so that when I move down, you don't lose anything. Note one thing here. Mayank, well, you must have studied this topic. Actually, your answer is also correct. Good. But then let's consider a few things. Or Mayank, now answer my question. The way I'm asking, now you answer my question. Note one thing. M1 which was at rest. Listen carefully. M1 which was at rest actually started moving. Right? क्या बोलते हैं हाथ कंगन को आरसी क्या? You can see it. M1 at rest, and now when I apply 5 Newton, M1 moves. So M1 which was at rest actually moved. And when a body at rest moves, then there must be a net force acting on that mass. Actually, whenever M1 moves with any acceleration, then you know that net force is equal to ma. So if M1 has any acceleration, then very sure that net force acts on m1. Look at it once again. When you applied this 5 Newton on m1, m1 which was at rest actually moved. So there must be a net force acting on m1. So if you see horizontal direction, horizontally if you see, then P minus T, or I can put it like this, P should not be equal to T. Why I have got T? Because the string became tight and I have written it T. Can be equal to P, can be more than P, and be less than P. That we will see, that we will study. That I don't know. That we will see. It's right now it is a question. I have just taken it as a T. But one thing is sure, because M1 was at rest and now it started moving, so P and T cannot be equal because there is some net force acting on it. And because it moved right, M1 moved right in my diagram, so P has to be greater than T. Do you agree? Do you agree? This is based on all the discussions that we have done so far. We have been talking about net force, net force, net force, and net force equal to ma. We utilized that net force concept to find normal reaction in the last week. And now in this week, we are utilizing to study motion of connected bodies. Body at rest started moving, so P should be greater than T. And if you use that popular equation, then P minus T should be equal to M1 into A. This I have got from here. Net force equal to MA. So P minus T should be equal to M1 into A. You will be surprised to know that you have learned something which is called force equation. Before this, in one of the classes, we talked about another important term which in short is called FBD, free body diagram. What it means? Free body diagram, that you consider any one mass and draw all the forces acting on it. So in this case, the free body diagram of M1, this side there is P, this side there is T. This is the horizontal direction, horizontal. You could have drawn vertical one also, and I'll do that, but because I don't need it, I'm drawing it with some different color. There will be some N1, there will be M1G, and because the block is not going up or going down, then N1 equal to M1G, that we have done in the previous week. That I am not touching. Today, what I am touching is the horizontal direction. This is the free body diagram. This is the complete free body diagram. Because there is no friction, I am not drawing any friction. P this side, T this side, P minus T should be equal to net force equal to MA should be equal to M1 into A. This is called the force equation for M1. Likewise, I can draw the free body diagram of M2. What would be that? There is a T acting on it. I hope by now you would have understood this thing. That this T, we have learned how to show this tension T. This T acting on it, and so the force equation for M2 will be T is equal to M2 into A. Because both of them are moving identically, both have same A, but I can prove it otherwise also. But for right now, you can assume that, see, if this string is not extensible, if it is an inextensible string, then whatever distance this block moves, the same distance this block will also move. Whatever will be the velocity of this will be the velocity of this one also. So whatever is the acceleration of this will be the acceleration of this one also. What is the condition? The string between them should be a string and not a spring. It should be inextensible. If it is inextensible, then acceleration of this block and this block will be the same. Displacement will be the same, velocity will be the same, and acceleration will be the same. If you solve these two equations, see, you have a variable t and variable a. You have a variable t, you have a variable a. If you solve these two equations, you get the answer that Mayank Gangwar was able to give, that t is equal to how much? I will solve it in front of you, or rather I will solve it first and then I will take you to another conclusion, which is a very important conclusion and a considered an important topic. But right now let me solve it for you. Oh. If you add these two, this equation which I am calling as equation 1 and this equation I'll call is at equation 2. If you add 1 and 2, then t cancels out. P is equal to m1 a m2a like this thing. So a becomes P upon m1 plus m2. And your P was 5 Newton and this was 3 kg and 2 kg. So it is 1 meter per second square. Now you use that value of A in either 2 or in 1 and you get the value of T. So T is m2 was 2 kg into A. So it is 2 into 1 and it is 2 Newton. It is 2 Newton. Likewise, you could have found it from this equation also. This is easy part. This is easy. Means anybody can solve these two equations. Rather, you have solved much bigger problems in class 8th, 9th, and 10th. You have done much bigger problems. These are much simpler problems. My question to you is this one. If any mass, this is one important conclusion that I want to draw from what we have discussed so far. If any mass moves with some acceleration, say this is mass m, this is say let me call it t1 and this is let's say t2, then t1 and t2 cannot be same. Rather, what we have is T1 minus T2 is equal to M into A. That net force, remember where is it coming from? Net force is equal to MA. This is coming from there. If any mass is accelerated, then the forces on two sides cannot be same. Had they been same, acceleration would have been zero. Something inbuilt. Now that creates a problem for me, that if I have a mass and I'm pulling it with a string. Now you know a string has a mass. A string has mass. Here T and TB cannot be equal. In a big problem that I am pulling it using a string, whether it is this string or it is this string, I am pulling it with a string and string has mass. If I consider any small portion of the string, tension at different points of the string cannot be same, because just now we have seen any mass, if it gets accelerated, then on the two sides of it, tension cannot be same, force cannot be same, TA and TB cannot be same. So one thing that I have got into is T at different point of a string is different. Tension at different point on a string is different. Wow. In that case, how do I ever find this T? It would mean that T at different points is different, different points is different. What do I do? Physics में एक चीज लिखी होती है, and you will start liking this language of physics. How can I consider the string to be massless? Let me tell you, where is that massless string placed? Let me show it to you so that when we are applying that, using that string to be massless, you don't get something a shock. This is too funny, too foolish. I can't believe this. I can't study this subject. You don't get into that problem. Okay, so let me draw one diagram for you. And this would be the last thing for today. And we will continue with this thing in the next class. This was your M2, and this is that string that we are getting in trouble. This is that string has mass. And I agree that T at different points is different. This string is connected to M2, and if I am allowed that draw the string which has a mass little thicker, and I redraw this diagram like this, that this is M2, this is that string which has a mass, string with mass, and this point is joined by this thing with something which I'm calling massless string, because there is basically no mass between that point. Now I can have tension different here, T1, T2, T3, I can have it different here. But within this much of region, I can assume T to be same. But remember one thing, whenever a mass comes in between, whether it is of the string or it is actually a block, say whether you say there is a mass m here and one string here T1, another string here T2, whether it is like this or the mass is of a string with mass, which is a usual kind of thing, common thing, T1 and T2 cannot be same. T1 and T2 cannot be same. Likewise, if I have T1 here and T2 here, T1 and T2 cannot be same. But then how do we adjust? How do we make the adjustment? Say this mass, suppose I want to find out T at the middle point Tm. What we do is we take this mass m by 2 separate, and we take this string m by 2 away, and this part we say are joined by a massless string, and we take T to be same everywhere. Everywhere T is same. T is same everywhere. Well, today we had just an introduction of how we deal with bodies when they are joined together. The number in between went up to 50 plus, which has come down to 46. So I can see few people lost the conversation. Well, this class has video recording available. The recording of this class is available. You can watch it again and again. That's the benefit of teaching on YouTube, that these classes are available to be watched as many times as you want to watch. Today we have seen one thing we learned was basic concepts, that what is tension, how do you show tension, that was different. But then if two masses are connected together, then what do? You draw free body diagram for the two masses, you write their force equations, and you solve those equations. Now we will see in the next class, we will see what if the masses are not just 2 but they are say 3, and say you are applying 10 Newton here, and say this is 3 kg, say this is 5 kg, and this is say 2 kg, and you want to find out T1, T2, things like this. And what if, who says that question can have only 2 blocks? What if the blocks are so many that you can't even think of applying the basic steps that I'm talking about? What were the basic steps that I was talking about? 1, draw free body diagram. 2, write force equations, and 3, solve the equations. And we have done for two bodies, two body system. Okay, M1 and M2, we did that. M1 and M2, we did that. We found out A and we found out T also. What if we have so many masses and you are asked to find T1, T2, T3, T4? Will you work hard and draw free body diagram for 1, 2, 3, 4, 5, and then 5 equations, and then keep solving them, and by evening you say, okay sir, I have got the answer? or are there better ways out? Ashi has written something. If the string is massless, the net force will be 0 because F equal to ma. No. If the string is massless, then T at every point is same, because let me redraw it. Say this string is massless, and you are writing here, say here the tension is T1, and say here the tension is say T2. Now if you write T2 minus T1 equal to ma, then massless means m is 0, and that implies T1 equal to T2, means T is same at every point of a massless string is because there is no m. So even if there is a, T1 and T2 will be same. Ashi, have I answered your question? Is it that to make T equal, we are assuming the string massless? If the string is mass, I think I have discussed, I have answered. In MA, M is not the string's mass, but the mass of the object. Yes, Mudit, yes. M is a mass. But then I said, if the string has mass, say if there is an M, then here and here, say T1 and T2, if there is some kind of mass here, then T2 minus T1 equal to MA. And if the system is getting accelerated, you cannot have T1 and T2 to be equal. Go through the recording. If you need to go through the recording, go through the recording. You know how to get in touch with me through the Telegram group or through WhatsApp. This Saturday at 4 o'clock, 4 p.m. onwards, we are starting a new series of weekend physics fun activities. And for this Saturday 4 p.m., we are going to start with few activities related to optics. The details of that course are on anytimeteacher.com. If you go to anytimeteacher.com and if you go through the courses, you will certainly be able to find that course. But I have posted that in the Telegram group also. So go to anytimeteacher.com. You will get the details of this course, new course of weekend fun activities, physics activities. This weekend, for this coming Saturday 4 p.m. we are going to have activities related to optics. So do join that course. That course is going to be more fun. It can get you a certificate also. Of course the certificate will be only from me. You are not going to get it from MIT or Harvard, but someday, who knows, you will get a certificate from there also. So find out, look out for that course. See you again on Saturday at 2 o'clock first, and then at 4. Sir, the website was showing 404 error at every page. Anytimeteacher.com. Ritesh Wadhwani, can you please send me a screenshot? Because this website works on a server which is rarely down. So Ritesh, send me the screenshot. Some children would have coaching at 4 p.m. I don't think coaching has started, but in case students have coaching at 4 p.m., I'll change the time. Aman, thank you for that input. In case some people say that they have coaching, then I'll change that class to some other timings. But then, because I take these classes on YouTube, the recordings are available. Well, then you can watch the record. Mudit, see, that's it. Okay, then see you at 2 o'clock first on Saturday, and then at 4 o'clock this Saturday. Thank you so much, and special thank you for being so much on time, rather before time. Thank you so much.